Today we're doing section 1.3, day 3, and today we're going to be graphing piecewise functions. So graphing piecewise functions, again, is something we did in Algebra 2. We're just going to revisit it. So here's our first function. It says that f of x equals 3x plus 1 if x is less than 1, and f of x equals negative x minus 3 if x is greater than or equal to 1. So again, the main thing I want you to notice is both of the domains are restricted. The only time I can use the top function is if my values are less than 1. The bottom function I can only use if my values are greater than or equal to 1. So we're going to make two t-charts. So that's what I have in this bottom right hand corner. So we're going to first start by putting if our x is less than or equal to 1, and we're going to put the function that corresponds to it. So the values that I need to pick have to be less than 1, obviously, but I also need to use the value of 1, so I know where my open dot needs to go, my placeholder. So I am going to plug in the value of 1, even though it's 1 is not less than 1. But, like I said, that's our placeholder, that's our open dot. So I plug in 1, 3 times 1 is 1, 3 plus 1 is 4. And maybe you want to write next to it, this is your open dot. And now I proceed from here, so all the values are less than 1. So I would say 0, negative 1, negative 2. So if I plug in 0, I get 1. If I plug in negative 1, I get negative 2. And if I plug in negative 2, I get negative 5. So now the second piece, let's just draw a little line here. These are my values that are greater than or equal to 1. And I use negative x minus 3 if I'm over here. So again, we're going to use 1. This one is a closed dot. So if I plug in 1, negative 1 minus 3 is negative 4. Then I'm going to continue to grow, but now my values are getting bigger than 1. So negative 2 minus 3 is negative 5. Negative 3 minus 3 is negative 6. Negative 4 minus 3 is negative 7. And now I need to get both of these pieces on the graph, and then we're going to talk about the domain and the range. So I'm going to plot my red with the red marker. So I go over 1, up 4, 2, 3, 4. Then I go 0, 1, negative 1, negative 2, and negative 2, 5. 2, 3, 4, 5. Okay, and this graph is going to continue to grow, pointing downward. So a lot of times students will have these dots and they don't know how to connect them. So remember, this dot up here, this 1, 4 is the furthest most up dot, and actually this dot's supposed to be open. Let me make that a little bit more clear. So 1, 4 is supposed to be open, and the only x values that I'm allowed to use are x values that get smaller, so I'm going to continue to draw this line going down in that direction. So now my second piece, I'm going to graph in blue. So this point is 1, negative 4. Then I have 2, negative 5, and then 3, negative 6, and so on. So I'm not going to have room to plot those points on my picture, but we have enough two graphs here to see. So I'm going to connect these, and it's going to, again, continue to grow further down. So last thing I want to discuss is our domain and our range. So our domain, let me get a better marker. Our domain, every x value will be able to be hit, even though 1 is an open dot here, it gets included down there. So our domain is negative infinity to infinity. Our range, we look at this graph as a whole, both the red and the blue piece, and I determine what the range is. So both of these pieces of graphs are going towards negative infinity, and the highest y value I have is 4. So my range is from negative infinity to 4, and 4 is not included. And again, you can kind of tell over here by our y values. Notice all of these y values would continue to go further down. Also with these y values, so this 4 is the highest y value I would have. So let's try another one. Okay, so here's our next one. F of x equals x squared minus 2 if x is less than 0, and f of x equals 3 if x is greater than 0. So again, we're going to start with making our two t-charts, and on your notes you could separate these a little bit more. For sake of space, I just have them condensed. So I would say x is less than 0, and when x is less than 0, my function is x squared minus 2. So again, we start with plugging in 0 because that's our placeholder, and then our values after that. This t-chart only allows values that are less than 0, so I plug in a -1, a -2, and a -3. So if I plug in a 0, I get a -2. If I plug in -1, -1 squared is 1, 1 minus 2 is -1. -2 squared is 4, 4 minus 2 is 2. -3 squared is 9, 9 minus 2 is 7. So our second piece is only our values that are greater than 0, and this piece is constant with a y value of 3. So again, I have this placeholder of 0, and this t-chart only allows values that are greater. Because this function has no area for an input, my output is a constant of a value of 3. So now I need to get this information on the graph. So 0, -2 is our first point, and this is an open dot because 0 is not less than 0, so that's why this is an open dot. -1, -1. -1, -1's over here. -2, 2. And then I have a -3, 7. 2, 3, 4, 5, 6. Somewhere all the way up there. I'm not going to be able to reach it. So this half of the graph is half of a parabola. My other piece is a constant piece. So my first dot's at 0, 3, and again this is an open dot because again 0 is not greater than or equal to 0. But all the other dots are closed because 1 is greater than 0, 2 is greater than 0, and so on. And this piece will continue to grow to the right. So again, now we determine the domain and range as this piece as a whole. So we look at this assuming it's working together. So going from left to right, notice the only x value that's not hit is 0. So we'll need a union. So our domain is -infinity to 0, union 0 to infinity. Our range, again going bottom to top, the lowest value we have is -2, and it's an open dot, so it's not included. And we go to infinity. So that is our range. So that's all for today. We're going to do some practice on graphing and evaluating these tomorrow.